I came back. We This time we will design this beam, this column for biaxial bending with a new method. In my previous video, I was discussing this where we combine these two and design this beam along y-axis. So this time I will show you a better method, but again this method will take some time. So have patience and make your brain cool. Okay, so I will erase this. So in the new method, what we will do, we will try to be little conservative. In that method, what we do, we multiply by this. That means, again, the same method based on the previous method, but little improvement. In this method, again same thing, we are combining these two, but we are decreasing by the short dimension divided by long dimension. So my short dimension is 16, long dimension is 22. Six plus, sorry, 8 plus 6 times 16 divided by 22. So 6 plus 8 times 16 divided by 22. This time I got 10.2 inch. So what we are doing here, this time we are multiplying by this. Now where I got it, it is just a like empirical way. There is no scientific way. Just to decrease the value based on the dimension. Now whatever we got it, then we will design along y-axis. Y-axis, same thing. But this time I will take use of this in the book. So if I design y-axis, then what is my gamma? Gamma is again 16 divided by gamma is 11 divided by 16, which is point. Last time we used it 0.69, and then E by S. Again, this portion is about y-axis. So E is 10.2. S means 16. 16. Okay, use a black color. So this will be roughly 0.64. 0.64. Okay, then we will go to graph. Graph is 6 and 7. We'll go to graph 6 and 7 and interpolate like for this. So when my gamma was say 0.6, what is my rho z? When my gamma is 0.7, what is my rho z? Again, to confirm, we are following the same procedure what I do it in the last time, except I multiplied this empirically. Then I will check. So if I go to 0.6 and 7, so if I go to 0.6, let us see, yes, 0.6. Oh, I did not find my Kn or Rn. Okay, so I did not calculate Kn or Rn. So what is my Kn? Kn will be Pn Az F prime C. That is 400 divided by 16, 22, 4. How much it is? So Kn will be 0.29. Rn will be Kn times E by S. So 0.29 times my E by S 0.64. 0.29 times 0.64 is 0.19. Okay. So 0.2919. So from graph 6, 2919. That means 29 here, 19 roughly here. I am getting roughly 1929. That means roughly 1 2 3 point something, say 3.8%. If I go to next one, 2919, it is roughly 2.9%. 1 2. Yes, so roughly 2.8%. No, your book got a little less value. I'm checking why your book got very less value. I got very high value. So everything E by A is 0.64, gamma 0.69, PN 400, AZ primacy point beta version between values, appendix A, graph 6 and 7. Yes, your book got very small value, I got very high value. So I should check one more time whether I'm doing right or wrong. So what about 0.6? Or I'm using the wrong chart or no? No, right side. So 0.29. 2919. Okay, check one more time. 2919. 3.5. 0.6. So I got here 1939. 2.4 actually, yes. So it is 2.4. Even 2.3. So 129 is here. If I go 29, yes, 2.4, right? This one, if I go again, 3.7, little bit. Okay, yes. Whatever, yes, we will go with this. So I got two value. 0.6 is for 3.7%, 0.7 is 2.4%. So I need the value for what is my gamma. Gamma is 0.69. That means close to here. So my gamma is in between 0.69. So very close to this number. So 0.25, it is increasing. Your book used 2.5%. Okay, it makes sense. So we got our gamma 2.5%. So, okay, so what is my rho z? Rho z is 0.025. Okay, then what is my AST? AST is 0.025 16 times 22. That means my reinforcement will be 8.8. 8.8 inch square. So last time we got 15 in my previous video without doing this. After doing this, I'm getting 8.8. Now we have to check whether this 8.8 is a good number or accurate number or no. How to check this? That is the checking, or that will take a long time. Okay, again we multiply b by a. That is empirically, that may not be right, may be right. So it is asked to make my design like economical. But after doing this, we need to check it. How to check it? I'm going there. So write our reinforcement 8.8. 8. How to check this? That is, the equation is called Bresler equation. Is P n x 1 over P n y 1 minus P n naught. Now this one is the capacity of this section, whatever we design, capacity of this section, and what is given 400. That means we will compare this with this. That is our target. We will calculate this here. We will calculate this here and compare with this. If this value is greater than this, our design is correct. Now what are these values? This is the capacity of column when EX exists, or right here when only. So capacity of my column, the load capacity of my column when only EX exists, no EY. What is this? Capacity of my column when only EY, only EY exists. What is this? Capacity of my column when there is no EX, no EY. That means no EX, no EY. That is that value. So we need to calculate this value, and we need to find it. We need to find this value, and this value, calculate this value, compare with this value. So that is our goal. So we will go there. Okay, so go there very quickly. So first we will calculate P and X. So first P and X, that is our target. What to do? Capacity of column when only EX exists. That means there is no EY, only EX. So do not make this mistake. EX. So what is our EX? 8. Then what is EX divided by ACE? 8 divided by 22. So 0.364. What is our gamma? Gamma is 17 divided by 22. 17 divided by 22. I got 0.773. Yes. Then what is my rho? My initial rho I got 8.8 divided by 16 divided by 22. Then my rho is 0.0227. Okay, then how to find this? That will be a challenge. Challenge is, okay, so we'll go to the curve graph. So this will be, say, graph 7. This will be graph 8. Because why 7 and 8? Because graph 7 is for gamma 7. So graph 7 is for gamma 0.7. Graph 8 is for gamma 0.8. So we will find these two value. We will use this value and this value. Find Kn. Kn here, Kn here. So, okay, so this will take time and it will need some passion. Okay, your book did not give us any answer here, so I will have to find. I will have to find it. So gamma 0.7. Now what is our reinforcement? 2.2%. So there are some line 2.2, 1, 2. So somewhere my line is here 2.2, my reinforcement. Now I do not know my Kn, I do not know my Rn, but I know my E by Ace. Now Rn is Kn E by Ace. So what I will do, okay, again this portion you need some attention. So I will assume the a value of Kn, whatever value. Say I am assuming Kn, say 0.2. Assume Kn 0.2. Then what is your Rn? Rn will be 0.2 times E by Ace. 3, 6, 4. Again 0.2 I just assumed it. 0.2 times 0.364. So 0.0728. I got a number. Okay, then what I will do, I will plot this value kn 0.2, Rn 0.728. Okay, so if I plot this, say kn to Rn here, I will get this value. Say kn 0.2 here, 0.2 here, Rn 0.0728 here. So you'll get this value. Then draw a line. Draw a line. Once you draw a line, this is my row. Come here. So that is the point we are looking for. So this value is just an arbitrary point, just to draw the line, and where this line is intersecting with my row, I'm going back, find my kn. So this value is my ultimate product. Same thing here. So locate 0.2, locate 0.0728, say it is here, and 1%, 2%, 2% is here. Draw this line, and when it's intersecting, this is my target. Okay. So if I use 0.7, 0.2, 0.07, I am getting very small number. Okay, 0.07. That means less than even 0.1. So it is here, 0.2 is there. If I draw a line this way, intersecting this kn value, I am getting roughly 0.3 something. So, okay, what about this one? 0.2, 0.07, it will be here. If I draw a line here and go, is point roughly k. So here I am getting roughly again not kicking. So 0.7 is going with 0.2 here, 0.10757 is here. If I draw a line, it is going this way. Then I am 2.2, I'm getting 0.55. So here I am getting kn is roughly 0.55, rough value. If I do here 0.2, 0.7, so 0.7 here, 0.2 here, if I draw a line, I'm getting roughly 0.44. So I'm getting here 0.44. Okay, it's challenge. So 0.44, 0.55, it is for gamma 0.7, 0.8, my gamma 0.77. So 0.44, 0.5, if I do in between, your book used 0.50. So my knx, your book used 0.50 kn. Okay, if I know kn, how can I find pnx? How? Because knx equals pnx az a prime c. So what is pnx? Is knx az a prime c. 0.50, 16, 22, 4. How much? 700. 700 say cube. So we got pnx 700 cube. Same way we have to find pny. Okay, Hopefully you understood what we are doing. We are trying to find this value when only Ex exists. Then we'll go to P and Y. Okay, I will delete everything. Do I need to delete everything? No. So when P and Y, EY is 6 inch, EY divided by A is, so this will be 6, this will be this way, so 16, and this value will be 375. Gamma will be this way, 11 divided by 16, so gamma will be 0.69. This will be same thing, and this will be, we have to read this value. We have to read this value and read this value. Okay, write it down here. So we got PNX 700, keep. Now we are finding P and Y. So if I read this value now, so now it will be for 7, 9. So grab 7 and grab 6. 7 and 6. If I use 7, what will be the change? Yeah, there will be no change because we already know this value. How much we got it last time here? Most probably 0.55. Most probably 0.55. Then we will go to 6. For 6, gamma is 0.6. I forgot what was the value here, 0.4 something or 0.5. Okay, let me find this value again. So 0.2, 0.7, if I go this way, 2.2, no, it was 0.45 something. Okay, so you can go back and find the value here. It was something like 0.4 point something. It was 0.5 that time. Okay, so if I go here, check again 0.2 and 0.07 here, if I interpolate to 0.2, yes, it was 0.2 something, I forgot, 0.4 something. Okay, then if I go to 0.6, 2 and 0.7, if I interpolate here to there, 2.2, it is coming 0.39. So this value is coming, say 0.38. This is 4. I actually forgot what was the value here. So same value for 0.44, 0.38. So this value 0.69, so close to this 0.44. 0.38. So actually we can use this with this graph 7 because gamma is 0.7, my gamma is 0.69, almost 7. So we will use this value 0.44 or whatever we saw it last time, that value. Okay, so if I delete it, so our KNX now 0.44. So KNY now, PNY AZ A prime C. So PNY is KNY AZ A prime C. So 0.44, write it clearly. It's taking a long time, but still though it is helpful. 0.44, 16, 22 times 4. Hopefully you can understand here. KNY 0.44, AZ 16 times 22. 16 times 22, A prime C 4. So after the calculation, 0.44 times 16 times 22 times 4. This time I got 6. say 20 keep. So PNY say 620 keep. We got that value. So we got PNX, we got PNY. Now we will get PNO. No EX, no EY. How to find it? So it is here. So PNO, that means it's nominal, so no factoring. So 0.85 A prime C AZ minus AST plus AST FY. So 0.85 for AZ 16 minus 22, AST is 8.8 plus 8.8 times 60. If I see your book, they did it, or I can, your book is not right actually. So 16 times 22 minus 8.8 times 4 times 0.85 plus 8.8 times 60. I got 1695 cube. Okay, then we will find this value. So, okay, I can write here 1 minus PNI equals 1 divided by 700 plus 1 divided by 620 minus 1 divided by 1695. So what is this portion first? That portion is 1 divided by 700 plus 1 divided by 620 minus 1 divided by 1695. Okay, I will erase this portion. So 1 minus PNI, I got 2.45 10 to the power minus 3. If I do the inverse, I got PNI is 408 keep, which is slightly greater than this value, PN 400 keep. That means okay. That means what we did here. So whatever trial design we did, that capacity is just over this. So very economical design. You can see here this time, that means whatever reinforcement we got is right. Now if it is not okay, if it is not okay, what would we do? If it is not okay, then we'll go back and increase this reinforcement. So that is to do, but luckily here is okay. And you can see the first time when we just added together, we got 15, almost double. So this method is better. At the same time, this method is labor intensive. You saw how many hard work we did it. So okay, so finally our reinforcement is 8.8 inch square. Then select bar and do the detailing. I will not go there to consume time. So hopefully you understood. And in your book there is more practice problem or example, you can work there. Thank you.